This video will talk about the sign test, which is a non-parametric test that can be used as an alternative to a one-sample t-test, or since a paired t-test is really just a one-sample t-test performed on the differences, it could also be used in place of a paired t-test. Recall that the conditions to use a t-distribution to make inferences about a single mean are that we need to have independence between observations, which we checked by making sure we had a random sample that included no more than 10% of the population. And the other condition we needed to satisfy is that the data need to follow a nearly normal distribution. That is a condition that can be relaxed for large sample sizes. The question becomes, what can we do if the sample size is small and the distribution is not nearly normal? The sign test tests hypotheses not about the population mean, but about the population median. The null hypothesis for the sign test would be that the median is equal to some hypothesized value, which we call m sub 0, versus the alternative that the median is not equal to the hypothesized value m sub 0. You could also do this. This is set up as a two-tailed test, but it could also be done as a one-tailed test, either left-tailed or right-tailed, if you wanted to see if the median were less than a particular value or more than a particular value. For example, a microbrewery has labeled the alcohol content of their double IPA as 8% alcohol by volume. They will use a random sample of 8 batches of their beer to test to determine if there's evidence that the alcohol content is mislabeled. In this case, the null hypothesis is going to be that the median is equal to 8, and the alternative is going to be that the beer is mislabeled and that the median is not equal to 8. I'll give a brief overview of how the sign test works, and then we will go through and see how those steps are sort of implemented in our example. The first thing we're going to do is for each data value, we're going to calculate a difference between the data value and the hypothesized median, m sub 0. Then we're going to count the number of those differences that are positive. Then we're going to use the binomial distribution to find a p-value. And then finally, once we have the p-value, we will use that to make an appropriate conclusion for our test. So here are the data for our example. The microbrewery collected data from 8 batches, randomly sampled, and here is the alcohol content for each of the batches. So for each data value, we start by calculating the difference between the data value and the hypothesized median. Since our hypothesized median is 8, for each data value we subtract 8.0 and we find the difference. And we can see, for instance, with the data value of 7.4, I subtract 8, I get a difference of negative 0.6. With the data value of 8.1, I subtract 8 and I get a value of positive 0.1, and so on. The next thing I do is I count the number of positive differences. Here I have 3 out of the 8 differences that are positive. And next I'm going to be thinking about how to use the binomial distribution to find a p-value. Remember that the p-value is the chance of seeing our observed sample, so the observed number of positive differences, or something more extreme, if the null hypothesis is true, and the null hypothesis is that the median is equal to m sub 0. So if the null hypothesis is true, then for each case that is randomly selected from the population, the probability that the calculated difference is positive is going to be 0.5, because there should be a 50% chance that each randomly selected value in the population will be greater than that hypothesized median, and a 50% chance that it will be less than the hypothesized median. If I let x equal the number of positive differences, then x is going to have a binomial distribution. The n for my binomial distribution is going to be the sample size, and p, the probability that each of the randomly selected values will be greater than the median, is going to be 0.5. So then if I were doing a right-tailed test, I could use the binomial distribution to find the probability that my binomial random variable x takes a value greater than or equal to the number of differences that I saw that were positive in my sample, and that would give me my p-value. If I were doing a left-tailed test, I'd look at the opposite tail, so it would be the probability that my binomial takes a value less than or equal to the number of differences that I actually saw. And for a two-tailed test, you need to think about a little bit, because it's going to depend on whether the number of positive differences is more or less than you would have expected to see if the null hypothesis were true. So that's the type of example that I'm working through here. And so we'll take a look at that. Okay, so in our example, 3 out of the 8 differences were positive. Remember that if the null hypothesis is true, since my sample size was 8, and my binomial distribution is going to have n equals 8 and p equals 0.5, the expected number of positive differences that I would expect to see if the null hypothesis is true is 4. And when I think about the values that x could have taken, I could have had anywhere from 0 positive differences up to 8 positive differences. I was expecting 4 based on my null hypothesis. Now, the p-value I'm going to find by finding the probability that x is less than or equal to 3 or greater than or equal to 5. Let's look at why. What I actually observed was that I had 3 positive differences. So I'm thinking about things that are as extreme or more extreme in support of the alternative. So if I was expecting 4 positive differences, I saw 3. So anything 3 or fewer is going to be farther from what I expected. So all of those things would be sort of things I'd want to be including when I'm finding my p-value. But since I'm doing a two-tailed test, I'm also interested in the chance that I'd see things equally far from what I would have expected. So 3 was 1 away, so things that are 1 away or more in the other direction would be 5 or greater. So when I'm trying to find the p-value, once again, I'm looking and I'm saying, okay, the p-value is the chance that I'd see something as far from my expected number of positive differences or further away in either direction. So when I want to use my binomial distribution to find this, I can substitute into my binomial formula, and I can find that my p-value is 0.727. Once I have my p-value, I'm going to use it to make an appropriate conclusion. Remember that my null hypothesis is that the median is equal to 8. My alternative is that the median is not equal to 8. The p-value I just calculated was 0.727. This is a very large p-value, so the evidence against the null hypothesis is weak, which means that there is not strong evidence that the median alcohol content among all batches of this microbrewery's double IPA differs from 8%. I hope you found this video helpful. I just want to kind of mention that the mechanics of going through and doing all of this is something that we're not going to focus a lot on. I mostly wanted to have you get some exposure to the sign test and to understand some of the sort of strengths and weaknesses of it. Some of the strengths of the sign test are that it does not require any assumptions about the shape of the distribution in the population. And so, it does give us an alternative to a t-test when we don't think we've got a nearly normal condition met. Another strength of the sign test is that it's easy to implement and understand for most people. It's actually kind of fun sometimes. Weaknesses of the sign test. One of the key weaknesses is that it ignores the magnitude of the difference. So for instance, if I had seen an alcohol content of 13% with a difference of 5, that would be treated in the same way as if I saw an alcohol content of 8.005, with a difference that is only 0.005. Both of those would be viewed similarly because both of them would be positive differences, and the sign test only focuses on whether the differences have a positive or a negative sign. And so because all of that information is ignored, this test turns out to be not very powerful in most situations. And so it's not generally the preferred way to do this type of test. We're going to see another type of test coming up called the signed rank test, which is a more powerful alternative. And so the sign test is relatively uncommon. Thanks. Have a good day.